So next is mechanism of lightning stroke. We have seen many times the lightning occurs, right? We have seen the lightning which will be transferred from the clouds to the ground. Many times we have seen that, and where very rarely we see that the charge will transfer from the ground to cloud. Right? Few people have observed that, and it will be very rare. And the time of that fraction of second it will be taken, where charge will be generated from the cloud, from the ground to cloud. So very rarely it will be observed. So that can be explained in the mechanism of a lightning stroke. Why it will happen, why it is, what type of stroke it is considered. Right? We also say it is a return stroke, where it is returning from the ground to cloud back. We'll see those things here. So here, in the mechanism of lightning stroke, when the electric field intensity, say at some point in a charge, where the concentrated charge within the cloud, if it exceeds 10 kV per centimeter. If you take a cloud, for example, if you take a cloud where the charge present within this cloud, the charge concentration within this cloud, if it is beyond 10 kV per centimeter, if it has reached this value, then what happens? The cloud has to discharge the charge through the lightning. So the lightning will occur if and if it is almost near to this value within the charge. And while this lightning, we might observe the halt in the lightning. You might observe there, right? So the lightning stroke will start from the cloud, some part till some part of the earth. It will, we can see that lightning path. Later, what happens? There will be halt. Suddenly there will be stop, and suddenly it will continue. So this halt is due to insufficient buildup of electric charge at the head of the that discharges. So this diagram will be explaining the discharges which is going to happen from the cloud to ground. So this point where you can see this is called as a head of the charges. Head of the charges, we can say. So I'll go back there. So this halt is basically due to if there is insufficient buildup of electric charge. I said that we need to have a minimum of 10 kV per centimeter. So this will be sufficient to create a lightning stroke. While discharging this, sometime what happens within the charge which is discharging, the voltage may drop down. So if that is happening, that's the reason the lightning will not be easily visible. So there will be a halt in the lightning, or it will stop. You might observe that. Like when you take a snapshot of any picture, you can see that still. So that's the halt we can say. So suddenly there will be a stop of a lightning charge. So later it will continue. After a short interval of about 100 microsecond, this streamer will again starts. We say this kind of discharge which is set as a streamer here. So it will continue. So once there is a halt, what happens? The charge will accumulate once again. Once again it reaches above this value. Once again the discharge will continue in the form of a lightning to the ground. So the total time required for such stepped leader. So the diagram which you have seen in the next slide, it is called as a step leader. To reach the ground may be 20 microsecond. So this is the time required to discharge from the cloud to the ground, in the form of a lightning. It will take just a 20 microsecond. So these lightning strokes and the electric discharge due to lightning are based on the streamers for a spark discharge. So where this spark discharge will explain regarding whenever we have a long gap distance between the electrodes, where your ground is acting as a positive, and your charges which is discharging from the cloud, if it is a negative, then the charge separation will be having very long gap. We also say with a non-uniform electric field here. It is not uniform, right? Where the cloud will be somewhere else and the ground is somewhere else. So within that, the field is non-uniform. It won't be uniform field distribution. So this is a diagram related to this, where you can see that the cloud is discharging with the help of the strokes. So where we say it's a stepped leader, so which is touching from the ground, from the cloud to the ground here. And also this leader, we say this as a leader, where leader which will be moving from this point to this point. You can see So this part of the cloud and when this part of the cloud, somewhere the part, only few part of the cloud will be touching the ground. The charge will be discharging the ground. Not entire part of the cloud will be discharging their lightning to the ground. So only few part will be having, because wherever we have a sufficient charge accumulated within the cloud, only in that cases the discharge will happen. So by the time the stroke reaches the ground and comes sufficiently near to the ground, if you see here, the charge is coming near to the ground. So the electric field intensity on the ground side will be sufficient large. So at this point, what happened? The ground potential will be very, very large, because already there is a huge amount of potential is releasing from the ground. Already if the ground is also having a high potential. So now what happened? So there will be a positive charge returned to the cloud. The positive charge will return to the cloud. You can see the next diagram here. So now it is happening in the reverse way. So from the ground, the charge is going to the cloud. So this is also called as a return stroke. So where your negative charges, positive charges will return to the cloud and neutralizing all negative charges, because this will be having a high potential. If any discharge is coming from the cloud, it will get neutralized, and hence heavy current flows through this path. Heavy current will flow with this path from the ground to cloud, and the velocity of this return stroke will be almost all 0.5 times of the velocity of light. So that is the speed of the return path, we can say, or we can say the range also 0.05 to 0.5 times the velocity of the light. This is the velocity of a return stroke from a ground to cloud. And in this case, as I mentioned, the current will be very heavy current when there is a return path, and the current in this case will be almost all 1000 amps to 250,000 amps. Very huge amount of current will be discharged from the ground to cloud with the return stroke. So this is how the mechanism of lightning will occur. So if there is a charge, sufficient charge accumulated, then it can discharge to the ground. And when the charge is discharging, if your ground is having very high potential, okay, sufficient potential is generated within the cloud, within the ground, then the reverse stroke of the lightning will occur with a speed of this range, and the current will be with this value. Very high value of current will be present there. And this return stroke will vanish before it reaches the cloud. You might have observed that whenever the lightning stroke occurs, within a fraction of a second, when it is returning, it will vanish. We can't even see what is the path where it is going back. Right? The fraction of a second it will come and it will go back. So the duration of this return stroke is almost about to 100 microsecond or even more. So this is a time taken for return of the stroke from your ground to cloud. So this is regarding mechanism of lightning stroke. So next we have over voltage due to switching surges, system fault, and abnormal conditions. So we know that in a power system, the over voltage is happening because of this condition. It could be your lightning, it could be your switching surges, right? Any system fault and any abnormal condition which is happening within the power system. So with respect to these cases, what happened? There will be a over voltage in your power system. So here there are few origin why this switching surges will occur within a power system, right? So whenever we are trying to make or break of electric circuit, whenever we are trying to make or break electric circuit within a switchgear, so it may result into abnormal over voltage. Suddenly I am opening and closing because the load is connected here. When I am trying to remove the load or I am trying to add sudden load, what happened? So there will be an abnormal over voltage which will be generated within the power system, which will be having a large inductance and capacitance. So this over voltage will be having very large inductance and capacitance. And the next, almost all there are the over voltage may be high as 6 times the normal power frequency voltage. So whatever the over voltage is generated due to switching, which will be 6 times the normal power frequency voltage. Just imagine the voltage magnitude here. And in other circuit, the circuit breaking operation, the switching surges with high rate of rise of voltage may cause repeated restriking of the arc between the contacts of circuit breaker, thereby causing a destruction of a circuit breaker contact. So whenever we are trying to operate a circuit breaker, so circuit breaker will be operated whenever the fault has been sensed. So in this case, the switching surges with high rate of rise. The switching surges at a high rate of rise of voltage. It's not courses, it's a causes. High rise of voltage which causes a destruction of a circuit breaker contact. So this high voltage will be generated which may destroy your contacts of a circuit breaker, where we have a contact like moving contact and a fixed contact within a circuit breaker. It will destroy that. So because of this is the origin of your switching surges. And next, under this we have characteristics of switching surge. We need to analyze what are the different types of characteristics will be present within the switching surges. What happened when you try to energize, or when you try to de-energize, when you try to connect any load, when a fault occurs, when you try to open this, what happens? What are the characteristics of this switching surge? So here there are different types of wave shape of switching surges which is given here, which may be generated within the power system because of these many reasons. The reasons which are quoted here, almost there are 6 reasons. Because of this 6 reasons, different types of waveforms will be generated within your whenever the switch is operated, the over voltage or switching surges will be obtained. So the first one, whenever we try to de-energize of transmission line. So you have a lines connected to some feeder. Suppose due to some maintenance, I want to de-energize that line, so that I want to do a maintenance. When you de-energize this transmission line or cable or any shunt capacitor bank which are used within your power system, or any capacitor banks for your power factor correction you might have used, whenever you try to de-energize these things, what happens? There will be a huge amount of switching surges will be present in the power system. That is the first reason. The second one, disconnection of unloaded transformers and reactors. Disconnection of unloaded. Even though the transformers and the reactors which is not connected to any line, if you disconnect that, because that will be acting as an inductor there, right? It will be acting as an inductor. So transformer enter, because we have a coils. So if you try to disconnect the unloaded transformer reactor, in that case also we may experience a switching surges. And there are few cases where we energize or reclosing of lines or reactive load. So the first point, it is similar to the first point. We have been removed the line. Now I am trying to add the line. After maintenance, we will charge the line, right? The charging of line is to say. The energization of or reclosing of line or reactive load. So in that case also we experience a switching surges here. And sudden switching off of load. Suddenly I am removing the load. In that case also the switching surges will be present. In short circuit and fault clearance, very important here. When you are trying to, if any short circuit occurred and I am clearing that fault, in that case also there will be sudden spikes in the voltage will occur due to this switching surges. And finally, a resonance phenomenon like ferro resonance, arc, ground, etc. So these are the few reasons for your switching waveforms which will be generated in the power system.